The tool and cutter grinder is designed to keep your cutting tools at their productive peak. This videotape will show you how to handle tool grinding jobs with confidence and efficiency. After viewing this videotape, you should be able to write down the safety precautions to observe in the machine shop and while cutter grinding, describe the setup procedures for the tool and cutter grinder, and describe the procedures for sharpening the periphery of an end mill. Whenever you are grinding and sharpening tools, you must observe certain safety procedures. Always remove watches and other jewelry. Wear safety glasses with side shields and a face mask. Wear a hat and an apron. Always use a dust collector when grinding, since most tool grinding is of the dry type with no coolant. And make sure wheel guards are in place before operating the grinder. The tool and cutter grinder is equipped with a 2-speed wheel head of 3,850 and 5,735 RPMs. The wheel can be rotated in either direction. This machine has duplicate controls for working in the front or rear of the table. The table slides and swivels on ball bearings. Spring cushion table dogs decrease the shock on the table on reversal. And a taper adjustment is used for making fine adjustments to the table. The wheel head column can be raised or lowered by turning the vertical adjusting hand wheel. A centering gauge is used for aligning the table to the center of the wheel head spindle. The wheel head spindle can be swiveled by loosening the wheel head clamping screw. The table and saddle move to and from the grind wheel using the cross adjustment hand wheel. For this demonstration, we will be sharpening the periphery of an end mill using the air-bearing fixture and a 4-inch Borazon flared cup wheel. The first step in preparing the machine for cutter grinding is to open the saddle of the machine to give yourself plenty of room to mount the fixture and wheel. Open the saddle until the buttons line up, and then lubricate the machine. Clean the table. From the right side of the table, slide in 2 T-bolts. Then clean the bottom of the fixture. Mount the fixture outboard, square to the table with a machinist square, with the base ears extended at least 1 inch over the edge of the T-slot. This overlap will keep the fixture from rocking. Set the axial tilt in the base turret to 90 degrees. Remove the stop collar, and then remove the spindle. Clean the air-bearing surfaces with acetone and clean rags. Replace the spindle and set the collar. This collar must not be tightened too tight, since the set screws may collapse the spindle, causing the air bearing, which rides on 1/10,000th clearance, to bind. Drain the moisture from the air line. Moisture will cause the bearings to rust and bind if not cleaned properly and often enough. Then connect the air. 100 pounds per square inch is maximum pressure, and 80 pounds per square inch is ideal. If the head floats properly, the spindle will float toward the fixture rather than toward the wheel. This could cause a safety problem and damage the equipment. Position the clearance collar to the 0 mark. Do not over-tighten the collar, as it will break. Next, check the tension on the dovetail slide. You should be able to adjust the slide for off-center movement with no up or down movement. The knurled knob is connected to a lead screw, which allows the finger arm to slide. Then the finger height is set using a centering level gauge or male center. Set the finger assembly close to the head for rigidity. Install a 3/8 inch collet and insert the gauge shank into the collet and tighten. The air bearing is locked down to a key device bolted to the fixture head. Move the air bearing spindle toward the finger and set it over and seat it home. If the bubble is not centered, loosen the set screws in the micrometer adjustment, and then level the bubble. Tighten the set screws and recheck the bubble for level. The finger can be in any horizontal position on the dovetail slide as long as the gauge can have a surface to bear on. To set the finger at center height with a male centering gauge, the setup procedures are the same, but the finger must be vertically on center. This allows for visually setting the finger height. After completing this procedure, check for any movement in the finger. Tighten the finger hold-down screw and micrometer adjustment. Check for a guide hole. If there is none, drill a clearance hole. Now tighten the knurled knob on the outboard arm. And finally, the dovetail slide. A carbide finger, shaped and tapered, will be used in this demonstration. Carbide fingers last longer than hardened steel. This carbide finger is used for both large end mills and end mills under 5/16 inch. The finger is shaped with a stand-up 30-degree angle with a 10,000th radius on the finger point. The finger is tapered on one side, getting thinner towards the point. Large end mills use the 30-degree angle towards the wheel. On small end mills with a high spiral or special rough and cut end mills needing peripheral sharpening, use the 30-degree angle toward the fixture head. This can be done by reversing the finger and rechecking the finger height. Check the finger for maximum contact by using blue dye on the finger point. Install the end mill in the proper collet. Rotate the end mill shank in the collet while turning in the draw bar. Rock the head towards yourself. Slide the flute over the finger. Adjust the dovetail slide so the finger is set close to the outer edge of the flute. The carbide finger is set 10,000ths to 15,000ths from the outside of the grinding wheel face. This allows for the flute to drop off the finger after making a grinding pass. This wrist motion is called pulling an end mill. A shiny contact point will appear. Using a diamond hone, you can hone in the finger contact point until a pass removes all the blue dye. The Borazon wheel is trued flat and generally has a 1/16 inch surface area. After mounting the wheel, check for tightness of the spanner nut on the hub and the spindle nut on the wheel head spindle. Set the wheel head to 89.5 degrees. Note the rotation so the wheel is always locking itself. To true the Borazon cup wheel, chalk the grinding surface with a grease pencil. Then mount the guard. Mount the diamond dresser and diamond nib. The diamond dresser is made of small particles of diamonds set in steel. Disconnect the air hose from the fixture and cover the fixture with a rag. To pick up the face of the wheel, use a reciprocating movement of the table and feed in the cross-slide wheel enough to gently touch the diamond nib to the wheel. It is a good idea to mark the in-feed rotation with a grease pencil next to the cross-slide wheel. Always dress the wheel from the outside to the inside. A feed of 2/1000ths is used for dressing the wheel. Stop the spindle. If the grease mark is gone, make a finish pass of 1/2 to 1/1000th, and then make a pass with no in-feed. Use a dressing stick. Scrub the wheel to remove bond around the Borazon grit. Now change the belt to alter the spindle RPM under the machine. A general rule is large pulley, small wheels, small pulley, large wheels. To check the setup of the airflow attachments, perform the following procedures. Connect the air hose to the fixture. Put a dull end mill in the collet and tighten. Set the finger close to the outer edge of the flute to be ground. Set the collar to the proper primary clearance angle. The carbide finger is set 10,000ths to 15,000ths from the outside of the grinding wheel face. Lock the table using the table stops. Turn on the spindle. Rock the fixture head toward yourself. Run the end mill over the top of the finger. Rock the fixture head toward the wheel. Run the end mill back and forth over the finger while feeding in. On light contact between the wheel and the outer cutting edge, stop feeding in and set the dial on the feed crank to 0. Make one pass on each flute. If you feed in too far, back off the hand wheel to remove backlash. Then turn the feed crank back in to within 0.02 from the original 0 setting. Again, make a light contact with the wheel on each flute. Then re-zero the dial. Check the end mill for the following items. Equal lands. Check for concentricity or runout. By checking visually and listening, the operator can tell if the periphery of the end mill is being sharpened properly. The primary clearance put on by the fresh grind should correspond with a factory grind. Equal width lands means each land has had the same amount of material removed, and the shank and the cutting edge are now on the same plane. Unequal lands. This means a taper is being ground on the end mill. The operator should notice visually and by listening if a taper is being ground on the end mill. The fresh lands will be heavy on the end toward the shank with the same amount on each flute. This indicates your wheel needs dressing. The shank and cutting edge will no longer be perpendicular to each other. Wobble or eccentricity. If all the lands end up different from each other, the operator needs to check the seating of the shank in the collet. By rotating the cutter shank in the collets 1 1/4 turns, you remove buildup on the collet pads and the cutter shank. Also, the shank will seat in the collet if the collet is drawn up while rotating the cutter. After a second pass on each flute, the lands should all be equal. If the cutter to be sharpened shows a buildup of material on the primary land, you should increase the existing primary clearance. This cutter was used on soft material. If the cutting edge is rounded or totally destroyed, you should decrease your primary clearance angle. This cutter was used on hard material. If the lands are concentric, complete the sharpening of the end mill periphery. Normal infeed is dictated by the cutting action of the wheel. Normal passes of 5/1000 are possible, or an overall removal of 10/1000 on the outside diameter to bring the cutting edge to a new surface. The secondary is then put on by rotating the collar to the end mill specifications. Grind until the primary land is to specification. The periphery of this end mill has now been sharpened. In review, you have seen the safety procedures to observe in the machine shop and while cutter grinding, the setup procedures for the tool and cutter grinder, and the procedures for sharpening the periphery of an end mill. Sharpening end mills in the machine shop will extend the life of these cutting tools. The skill and knowledge of cutter grinding is an important part of the machinist's trade.